Screen recording, we're in the motion unit. Our statement of inquiry is using mathematical models, we can understand the movement of objects within systems in order to make predictions about our world. I think that's a pretty cool reality that we can make predictions about our world using those mathematical models. Today we're going to start off by defining motion. We'll define speed and we'll define velocity finally. And then you're going to perform an experiment. You're going to be out collecting. It's going to be running and walking speeds. We'll tell you how to measure them, and then you're going to end up calculating them and practicing some calculations next class. Let's start by getting these definitions today. Go over to the motion notes, which is in the PDF that was shared with you on Google Classroom. Go ahead, pause your video, get these out. I'm going to start into them right away. Here we go. How do we define motion? An object is considered to be in motion when its distance is changing over time compared to a reference point. So it's going to be, we got to be comparing it to something. That's going to be that whole point of that video, that everything is relative. It depends what you're comparing it to. So when is something considered to be in motion? An object is in motion exactly when those things above it are happening. Is in motion when the distance to a reference point is changing over time. Okay, so what is speed then? Well, speed is the distance traveled per unit of time. That means it is rate of change of distance. Okay, so the distance traveled by that object per unit of time, it means it's the rate of change of distance. So it's how far you are going in a certain amount of time. So I'll give you, for instance, we've got the classic for instance of 50 miles per hour, right? 50 miles per hour means that equals every hour you travel 50 miles. That's pretty obvious to some kids, but when you start to think about it, it gets really cool. So speed is how far you are going per unit of time. It's your rate of change of distance. Let's now compare that to velocity. Velocity is very similar to speed. It's just like speed, except velocity is a little more precise. Velocity will include direction in the measurement. So for instance, we'll take that example of, we'll do 55 miles per hour. How about 55 miles per hour? That could be a speed. We could turn that into a velocity if we know the direction of travel. So if we instead say, well, it's not 55 miles per hour only, it's 55 miles per hour north. Now all of a sudden that's a velocity because we know both the speed and the direction. Let's talk units real fast on units. We're going to need to know the units for physics and science class. Your units are going to be, it's going to be all sorts of different units. The official ones of science will be meters per second, which will abbreviate m/s. But you can also use, we'll see kilometers per hour, we'll see miles per hour, which is abbreviated mph. You're going to see all sorts of different units this year, this unit. Oh boy. Okay, but we'll do meters per second a lot. Okay, we're going to move forward into this lab. You'll scroll down, you'll see we'll learn our calculations next class. First, we're going to be on how fast is your family, a distance learning lab. At this point, I want you to make a decision. If you think that you want to read these lab directions on your own and just go ahead and do the experiment, you go ahead. However, if you would like me to read through the directions with you so you can make sure you're understanding what to do, if that helps you, I'm going to have you watch the next video. Okay, so you got a choice. You can either go ahead and just read the instructions and do the lab, or you can get onto this next video and you can read through the directions for the lab with me. Have fun.